Hey pre-calc, hopefully you guys are having a good day. So we are gonna start 2.2. The title is called the graph of a function. Okay, so we are going to define, I'm saying so a lot. We're defining the definition, one definition for 2.2, vertical line test theorem. Okay. Vertical line test theorem states that a graph is a function if and only if, okay, in the future, we're going to shorten that up and do IFF, okay? So IFF spells if and only if. If and only if every vertical line intersects, so if every vertical line intersects the graph, can you tell me how many times? A graph is a function if and only if every vertical line intersects the graph. At most 1 point. Okay? That means you may not have 2 points intersecting the graph. So for a graph, one of these four to be a function, so let's do example 1 because it's going to relate to this definition. Okay? Let me zoom in a little bit. Example 1, identify which graph is a graph of a function. Remember, in 2.1, I gave you an equation, and I said, hey, is this a function of x? Okay, is y a function of x? Now, for this one, I'm just going to give you a graph, and I'm going to ask, are these functions or not? So the first one is the parabola. Notice how I have two vertical lines drawn, two dashed lines here drawn. Okay, let's zoom in a little bit more. Two lines drawn. Here we go. Okay. Focus. Okay. So, and I can draw more than just two lines. Remember, if every vertical line, and a vertical line is also known as a pencil line test, okay? If I put a pencil anywhere I wish, does it intersect more than 1 point? Okay. And we don't want it to be more than 1 point. We want it to be at most 1 point. It doesn't have to intersect, but if it does, it can only be one time. So vertical line number 1 intersects 1 point. It feels good. It might be a function. Let's do a couple more vertical line tests. This one also intersect 1 time. How about if I want to draw another one here? This is also 1 time. Remember, I can draw as many vertical lines as I want, as long as each line intersects 1 time. So identify which graph is a graph of a function. So this is definitely a yes. Okay, this is a function. B, this is a graph of y equal x to the third. Okay, so I have one vertical line drawn, but technically I can draw more than one vertical line. I can draw as many vertical lines as I want, as long as each vertical line intersects 1 point. Okay, so if I can draw this one, that's 1 point. This one, that's 1 point. This one, that's 1 point. So guess what? This is also a yes. Okay. Okay, moving on to part C. Here we go. Part C, we have a sideways parabola. If I draw that vertical line, notice how it intersects at two different places. So immediately, I can say that this is not a function. Okay. Remember, I only need to have one vertical line test fail for the entire function to fail. So this is no. This is not a vertical line test. Oh, that's a weird box. This does not pass the vertical line test. All right, so what I'm going to ask you to do is tell me if this is a function or not, and you're going to do it on your own. Okay? So do that on your own for me. And then we're going to move on to example 2. Here you go. I'm going to zoom out just to get a big picture of example 2. Moving on up already. and then zoom back in just to get a clear, more defined graph here. Okay, because this, if it's blurry, it's going to be difficult for you guys to see. Okay. Example 2, obtaining information from a graph. I'm giving you a graph here. Okay, it's definitely a function because if I draw my vertical lines anywhere, it doesn't matter, it will only cross or touch or intersect. It will only do that one time. Okay, so the first question is, from this graph is not an equation, and so don't try to write an equation. What are f of 0, f of 3 pi over 2, f of 3 pi? Okay, so the first one is f of 0. What is the value for f of 0? And remember, these right here, okay, these things right here, these are all the inputs. So what I'm asking you is, hey, when the inputs are 0, 3 pi over 2, and 3 pi, what are the outputs? Okay, because I already know the input. I'm searching for the output for when x is 0. So let's look at the graph. X is 0 is right here. Okay, this is x at pi over 2. This is x at pi, this tick mark. This is at 3 pi over 2 because I'm just reading the dots, okay, and so on and so on. So when x is 0, the output, which is y, is 4. By just looking at the graph. We don't even have to do any math, okay? So the second piece of that is f of 3 pi over 2. So when the input is 3 pi over 2, what is my output? So now the input represents x. So let's go on the x-axis. Woo, 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 woo. I pass 3 pi over 2. Back up. Beep, 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 beep. All right, here's 3 pi over 2. Okay, this is the tick mark. Now when x is 3 pi, oops, I'm thinking that's wrong. That is not 3 pi over 2. That is 2 pi. I lie. 3 pi over 2 is back here a little bit more. So beep, beep, beep. Here we go. Here's 3 pi over 2. So when x is 3 pi over 2, this is x. I'm looking for the output, which is y. So when x is 3 pi over 2, the output is 0. Okay? All right, now I'm going to ask you to find f of 3 pi for me. Okay, write your answer. And yes, you are doing this on your own. All right, take a second. Hit pause if you need to. Write the output for when x is 3 pi. Okay. B, what is the domain of f? So let's check the graph out. Notice how we have closed circles on the ends here? That means it does not go forever. Okay? So if it doesn't go forever, but the smallest x value, notice how it ends right here. So the smallest x value is 0. The largest x value is all the way over, not here, all the way to here. And if you look at this, okay, that is at 4 pi. Because I am including these two endpoints, because they are closed circles, I'm going to use the square brackets. Okay? And if you're more comfortable with writing it old school way, hey, by all means. But from now on, I'm only going to be using intervals, okay? B, so the domain is 0 all the way to 4 pi inclusive. What is the range of f? Okay, the range is talking about the y values. How high does it go and how low does it go? So if you look at the y values, the lowest is at -4. In the interval notation, you write smaller number first. And it goes all the way to boop, 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 boop. The highest value on the y is 4. So, and I am going to be including these two endpoints because as you can tell, these are all part of my range. Okay. And again, in an interval notation, we're going from small to big, never the other way around. Part D, list the intercepts. Okay. Intercept means I'm going to have x-intercepts and also y-intercepts. So x-intercepts. Here we go. List the intercepts. X-intercept is when y value is 0. Okay, so I'm going to zoom out because I'm going to need to show you how to write the answers all the way over here. Okay. So when y is 0, that means all of the stuff that's on the x-axis. So it looks like I have one answer, two answers, three answers, and four answers. And the nice thing about this graph is, look, they've already labeled these things out for you. So all you got to do is copy it right back. So here we go. The first intercept, x-intercept, when y is 0, it's pi over 2 comma 0. The second x-intercept, it's when y is 0, again, and x is 3 pi over 2. The third one, I'm kind of running out of space, so let's write it right here. 5 pi over 2, comma 0. And the last one, 7 pi over 2, comma 0. So those are all the x-intercepts. Now we also need to list the y-intercept because it says list the intercepts that include x and y. Y-intercept meaning that it needs to touch or cross over the y-axis. Well, if you look at the graph, there's only one location that touches the graph at y-axis. So it's at 0, comma 4, or aka y-intercept is when x is 0. Okay? So we have a total of 1, 2, 3, 4, 5 intercepts altogether. Next, after D, we're going to go to D, E, F, G. So we'll go D, E, F, G in that order. Okay? E, how often does the line y equals 2 intersect the graph? Okay. Do you know what the line y equals 2 looks like? What direction is that? Is this way? Up and down? Vertical? Or is it a horizontal? This way. Okay. If you said it's a horizontal line, then you're right. So let's graph it out. Line y equals 2. Let's draw that line. Here we go. Line y equals 2. And this question, I'm going to ask it so often on a lot of exams, so make sure you understand how to do this stuff, okay? How often does the line y equals 2 intersect the graph? Okay, let's count. 1 time, 2 times, 3 times, and 4 times. It's that easy. 4 times. Okay? It's easy if you understand what the question's asking you to do. F. For what values of x is f of x greater than 0? Okay, so let's talk about this question. F of x is the same as, oops, you can't see that, as y. So f of x is the same as y. So if I wanted to, I can just say, right, for what values of x is y greater than 0? So that leads me to look at my graph. I'm going to erase this line. And if you don't want to erase, that's okay too. Okay, so here's my graph again. So y at 0, this is the line y equal to 0. Okay, y equals to 0 is right here. That's the x-axis as well. But I don't want it to be equal to, I want it to be bigger. Okay, so if I want it to be bigger, then I need to look above. Okay, so all of this stuff right here is bigger than 0. Would you agree? All of this stuff right here, it's also bigger than 0. And all the stuff right here, it ends right here, so I can't really go over that. So I'm just going to shade in that, okay? So all of that right there is bigger than 0. But I don't want to find out what y values are. I want to find out what x values. So in this case, interval notation is going to come in handy. From 0 to pi over 2. So this is when x is 0, all the way to pi over 2. Because when x is 0, y is 4. 4 is definitely bigger than 0. So I am going to include 0 all the way to pi over 2. Okay? But when x is pi over 2, y is 0. Well, 0 is not greater than 0, so I'm not going to include pi over 2. Or I have another spot from here to here. Because this whole piece right here, can you see that mountain? It's also bigger than 0. So, at 3 pi over 2, all the way to, over here, 5 pi over 2. I'm not including those endpoints because at 3 pi over 2, y is 0. And 0 is not greater than 0 because it's asking you to find things that are greater than 0. Or I have another location. When x is between 7 pi over 2 all the way to the last dot is at 4 pi. So I have to stop at 4 pi. Okay? Now I'm not including 7 pi over 2 because similarly to these, at 7 pi over 2, y is 0, and 0 is not bigger than 0. But when x is 4 pi, y is 4, and that is larger than 0. So therefore, I can include the 4 pi. Okay? All right, our next task is for what values of only, remember this, from 0 to 4 pi of x between 0 and 4 pi is when f of x equals to negative 4. So I'm going to ask you, f of x is the same as what? F of x is the same as y. Okay? So I'm asking, hey, find me x values for when y equals to negative 4. That's really what I'm asking. Okay? So let's look. It's y negative 4 above or below? You're right. Y is negative 4 is below. So here is y equals negative 4. Y equals negative 4. Awesome, right? If you look at this, how many times do you think y equals negative 4 intersects the graph? Hopefully you're saying 2. So we're going to end up with 2 answers. And we're not going to have an interval. Y equals negative 4 at 2 places, when x is at pi and when x is at 3 pi. Okay? It's not an interval notation because there are not unlimited number or things in there. It's just 2 dots. Okay? When they're dots, then you're just going to give me single value. When it's a list of things for you to write down, then you're going to give me an interval. Okay, so that's what that is. All right, so let's look ahead. I want to show you a couple of things before we conclude our video notes. An example in section 2.2 is quite short. We have example 3, and we have a check for understanding here. And we have a, here we go, and we have a word problem. Okay, so on the next video, we're going to do example 3 and a word problem. But right now, we are just going to end at example dos. Example dos. Okay. So before I go, here's our joke, our toddler joke of the day. Why don't aliens eat clowns? Why don't aliens eat clown? Because they taste funny. Ha ha ha. All right. Until next time. Adios.